In section 7.4, we look at the area of a triangle. Now, we already know how to find the area of a triangle from geometry. We know that the area is 1/2 multiplied by the base of the triangle multiplied by the height of the triangle. So look at the diagram we have here. We have a triangle ABC. The base of the triangle is side C with the way that this triangle has been drawn. And we have drawn the height here. So according to this particular picture, we know that the area of this triangle is equal to 1/2 multiplied by the base here, which is C, multiplied by the height, which we are calling H. But what is H? Well, if you look at the height and the way that it's been drawn, we have a right angle here, which means that this triangle is a right triangle. And because we have a right triangle there, we know that if we look at this angle here, the sine of angle A is equal to H divided by B. Multiplying both sides by B gives us H is equal to B times the sine of A. And because H is equal to this, we can replace the H in the formula here with that. And if we do so, we get 1/2 times C times B times the sine of A. And if we rewrite this formula, we can see the area of the triangle is 1/2 times B times C times the sine of A. And this gives us a way to find the area of a triangle if we know side B, side C, and angle A. Now, if you look at the picture, side B and side C are these two sides, and angle A is that side. And so this is a way for us to find the area of a triangle if we know side, angle, side. Now, another thing to note here is that we could have drawn the triangle differently, and we could have found two other formulas for finding the area of a triangle. And those formulas would be the same as this formula, but with the sides in different locations. And so we would have area equals 1/2 times A times C times the sine of B, or area is equal to 1/2 times A times B times the sine of C. All of these formulas are the same, right? They are all formulas that allow you to find the area of a triangle if you know two sides and the included angle. So let's go ahead and take a look at an example. So I have summarized those formulas up here. The way we find the area of a triangle if we know side, angle, side is by any one of these three formulas. And again, these formulas are all essentially the same, okay? So in our first example, it says to find the area of a triangle ABC if angle A is 35.1 degrees, side B is 2.43 centimeters, and side C is 3.57 centimeters. So notice they have given you angle A, side B, and side C. And so we're going to use the first formula here to find the area of this triangle. Now, another thing to notice about the area of the triangle is you'll notice that they let the letter S represent the area. Now, the reason they do that is because typically, we use the letter A to represent the area, but the reason they use S to represent the area is because in the triangle we have angle A. So they don't want to call the area A because that could be confusing. Okay, so that you'll notice that throughout the section, they always refer to the area of the triangle as this letter S. All right, so to do this particular problem, we have the area S is equal to 1/2 times B times C times the sine of A. And this is equal to 1/2 times 2.43 centimeters times 3.57 centimeters times the sine of the angle 35.1 degrees. And all we need to do now is plug this into a calculator. And if we round this to 3 significant digits, we get an area of approximately 2.49. And this will be centimeters multiplied by centimeters. That's centimeters squared. And the way we usually say that is square centimeters. So 2.49 square centimeters. And one other note is when I plug this into the calculator, notice that instead of typing 1/2, I just typed 0.5. And then the rest you can see is pretty much just like you would read it here. And the other thing to note is that I used parentheses when I typed it in to match what I have here, but you could also just use the multiplication symbol in between these as well. Okay, let's take a look at another formula. So here I have one of the 3 formulas from the previous page. Area of the triangle is 1/2 A times B times the sine of C. And I want to try to get a different formula. Let's remember that from the law of sines, we know that A divided by the sine of A is equal to B divided by the sine of B. And if I multiply both sides by the sine of B, notice that these will cancel out and we can solve for B, and B will be A times the sine of B divided by the sine of A. And what I can do is I can take this expression and I can replace side B in the formula here. And if I do that, this formula becomes S equals 1/2 times A times B, which is A sine of angle B divided by sine of angle A, multiplied by sine of C. Now let's remember that these here can be put over 1, and we can make this into 1 fraction. And if we do that, we have A times A is A squared, sine of B, sine of C, divided by 2 times the sine of A. And so this is another formula for finding the area of a triangle. And this will work for the situations where we have angle, angle side, or angle, side, angle. I want you to notice that in this formula, you have to know all 3 angles and one of the sides. So the reason this formula works for the situations angle, side, angle, and angle, angle, side is because if you know 2 angles of the triangle, you automatically know the 3rd angle by using subtraction. So what we have here are 3 new formulas. So here are those formulas. And you'll see the first one here is the one that we just found. But the other 2 look just like it. So notice that all 3 of these formulas have the same structure. Okay. So how do you remember these? Well, here's how I remember them. You know that one of the sides is squared, right? Whether it's A squared, B squared, or C squared. In the bottom, you have a 2 in all 3 of these. And the angle in the bottom matches the letter of the side on top, right? So notice that B here matches the B here, C here matches the C here. And then the other 2 angles on top are just the angles that are different from the one in the bottom. So it's kind of an easy way to remember these formulas. All right, so for our second example, it says to find the area of a triangle if we know that angle A is 24 degrees and 10 minutes, angle B is 120 degrees and 40 minutes, and side A is 4.25 feet. So because they gave us side A, we know that we are going to be using this formula. And in order to use this formula, we need to find angle C. We know angle C will be 180 minus angle A minus angle B. And this can be done on a calculator. You can subtract these degrees, minutes, and stuff from each other. I'm just going to post it here. Let's go ahead and plug this in. And this is equal to 35 degrees and 10 minutes. Or you could also say 35.1666, etc. degrees. Doesn't matter really which one of those that you use. I'll keep it in degrees and minutes though, since this is the way we have it. And now I can find the area. We'll say S is equal to, we have A squared, that's 4.25 squared, times the sine of B, that's the sine of 120 degrees and 40 minutes, times the sine of angle C. Angle C is 35 degrees and 10 minutes, all divided by 2 times the sine of angle A, which is 24 degrees and 10 minutes. And then we'll type this into our calculator to get an approximation. And we can see that we get approximately 10.9. And this was given in feet, so the answer will be square feet. So technically here we have 4.25. We should have feet in there. And when you square the feet, you get square feet. The last formula that we're going to talk about regarding area is a formula called Heron's formula. And this is the formula that you can use when you have 3 sides of a triangle. To use this formula, we need to first find something called the semi-perimeter of the triangle. The semi-perimeter is basically just the perimeter divided by 2. So the perimeter of a triangle is A plus B plus C, and if we take half of that, we get the semi-perimeter. And then the area of the triangle is given by this rather simple formula. It's the square root of the product of the semi-perimeter with the semi-perimeter minus A, the semi-perimeter minus B, and the semi-perimeter minus C. So let's take a look at the example we have here. Find the area of the triangle with the 3 sides, 12 meters, 14 meters, and 8 meters. So first let's find the semi-perimeter, which is 1/2 multiplied by 12 plus 14 plus 8. If you do the math on this, this is 1/2 times 34, which is 17. Okay, and technically that would be in meters. All right. That's the semi-perimeter. Now that is a small s, by the way, because a large S is the area of the triangle. And we know the area of the triangle is a big square root. And we're going to start with the semi-perimeter, so that's going to be 17 meters. And then that's multiplied by, next, the semi-perimeter minus A, so that is 17 meters minus 12 meters, multiplied by the semi-perimeter minus B, which is 17 meters minus 14 meters, and finally multiplied by the semi-perimeter minus C, which is 17 meters minus 8 meters. And this is the square root of 17 meters times 5 meters times 3 meters times 9 meters. And then we can just type that into a calculator. And you can see what we get here is approximately 48. And then you have the square root of meters times meters times meters times meters. So that's going to be meters squared. Now the reason for that is because you basically have the square root of meters to the 4th power. And when you get that, the square root of a 4th power just gives you a 2nd power. So we end up with approximately 48 square meters. All right, so in this section we have basically 3 pretty simple formulas to allow us to find the area of a triangle.